About quadratic functions, and you would have spent so much time doing quadratic functions in your Algebra 2 class. So this should be a review about the three main ways that you would solve a quadratic. I always used to, when I taught Algebra 2, I used to always try to help my students think of it as like layered or tiers. So like tier one, the one I'm hoping to be able to use is factoring. If I can't factor, then I'm looking to see, can I use completing the square? And if that's going to, not be something I can do pretty efficiently, then I use the quadratic formula. The quadratic formula, yes, can solve all of them, but really, truly, the most efficient students and teachers solving quadratics are going to be using the quadratic formula as like a last resort, right? You don't go to that first because a lot of times it can be very clunky, a lot of work to do, and in the end, you might find, you know what, I could have just factored this right away. So we're going to be using this first method. All right, it's only useful, obviously, if we can factor it, so it can be factored. Factoring means finding expressions that can be multiplied together to give the expression that we start with. Okay, now it has all these steps that I used to use, but I'm going to show you the way that a lot of you, if you had, or all of you, if you had Miss Wilhelm last school year, would have used this slide divide bottoms up. It is the same process as what I used to teach, this factoring by grouping, but it's just a much faster way to do it. Okay, so before I do that, let me state one more thing. This zero product property, it's something that you would have discussed probably really briefly. It's the same thing as I did when I taught Algebra 2 was I went over this very briefly, but it kind of drives everything we do here. The idea that if you have two factors and you have one of them is zero, the whole product becomes zero. So like 6 times 0 is 0, 0 times 4 is 0. So essentially what you're trying to do is you're trying to factor and then set one of those factors equal to 0. It doesn't matter what the other one becomes because if one of them is 0, the whole thing is 0. So that's kind of the whole kind of reason that this exists. And I know you can get bogged down in practicing, but just have that in the back of your mind that that's why we're doing this. Okay. Now, on this one, when I look at it, we have A equals 1, right? This is standard form. B equals 1. And C equals -6. So because A is 1, I'm going to do the most basic factoring you would have learned in probably 9th grade. And I'm going to write my two parentheses or sets of parentheses to factor. I've got x times x, which gives me x squared. And I'm trying to think of factors of -6 that add to 1. So factors of -6, that's my factors of C, that add to B. So factors of -6 that add to 1. I'm going to use +3 and -2 because 3 times -2 is -6 and 3 plus -2 is +1. So using this zero product property, if I set x plus 3 equal to 0 and get x equals -3, it wouldn't matter what happens in my other one. -3 will make this entire equation 0. Same thing with the other factor. If I set x minus 2 equals 0 and get x equals 2, no matter what happens on the other one, 2 minus 2 is 0, so the whole product must be 0. All right, let's try another one like that where it's hopefully a little bit straightforward here. So A is 1, B is 8, C is 15. So I'm doing the same thing. I need factors of C that add to B. So factors of 15, so x and x. Factors of 15 that add to 8. So that's 5, so plus 5, and plus 3. So setting each of these equal to 0, I can find my two solutions. So -5. And setting this one equal to 0, I get x equals -3. All right. Now, this one is a special case. X squared minus 25 is one of my favorites. And if you've had my class in the past, which I don't think any of you had my Algebra 2 class, but what I like to do is when I see this is I actually think about this acronym, DOTS, right, which stands for the difference of two squares. And it's something your Algebra 2 teacher would have gone over in this basic form, a squared minus b squared factors as a minus b times a plus b. So when I look at this x squared minus 25, I immediately see two perfect squares, x squared and 25, and write x minus 5, right, because the square root of 25 is 5, times x plus 5. You could also think of this as, well, your middle letter b is 0, so you need factors of negative 25 that add to 0, so it'd be positive 5 and negative 5. That is not the thinking I want you to do. I really want you to focus on recognizing dots. So I have x minus 5 equal to 0 and x plus 5 equal to 0. So my two solutions are positive and negative 5. So plus or minus 5. All right, now here's where we finally get to the slide divide, slide factor, and then divide bottoms up. So here's the process. I'll write it again. So you have 4x squared plus 15x plus 9. All right, so the slide part, again, this is review for any of you that had Miss Wilhelm. You're going to slide the 4 all the way to be with the 9, and you're going to multiply it. So x squared plus 15x plus now 36. Now you're going to factor this just as if it was the last two questions we did, where you write down your x times x, and we want factors of c, which is now 36, we've changed c, that add to b. So factors of 36 that add to 15. So that's 12 and 3. Okay, 12 times 3 is 36. 12 plus 3 is 15. Now that's the factor part. Divide means you take those two numbers you just wrote and you divide by that a that we just slid at the very beginning. And if it can divide, right, 12 divided by 4 is 3. That one's done. And since 3/4 doesn't divide nicely into a whole number, that's where you have the last step, which is the bottoms up. So that 4 is going to move to be in front of this x to write 4x plus 3. And if you were to multiply that out, you would get what you started with, 4x squared plus 15x plus 9. So I would recommend this strategy. And again, if you've had Miss Wilhelm, you probably mastered it already. If you haven't, a little practice will help you figure this out. So now we'll find out what makes them 0. I'm going to skip that next step because I've written it enough. So that's negative 3. Now this one I will work out if you need it. I don't anymore because you'll see like a pattern develop. So you have 4x equals negative 3, and if you divide both sides by 4, you get negative 3/4. What I always tell students is that when you get to this step here, right here, and you have your two factors, if one of them has a value that's not 1 in the a, like this 4 right here, right, that's going to be in the denominator in your solution. So you think opposite of this number, and you divide by that number in front. It works every time. All right, let's do one more factoring. So I'm going to factor out a common factor here. It looks like they all share that x, and I'm going to factor out the negative x so I can deal with, now whatever's left will be positive in here. So 3x squared plus 5x plus 2. All right, and now I'm going to focus on just the 3x squared plus the 5x plus 2. All right, with my slide divide bottoms up. All right, so I'm going to slide the 3 to write x squared plus 5x plus 6. Factors of 6 that add to 5, that's going to be x plus 3 times x plus 2. Again, don't forget to divide those by the a that we slid, which was 3. So I have x plus 1, and then that's the bottoms up one, which is 3x plus 2. Don't forget to bring down the negative x. Okay, let's see if you can see the pattern here that I kind of showed on the last one. This negative x out front, whenever you have just a variable x, that means 0 is going to make it true, right? 0 times anything is 0. This second one is going to be negative 1, right? The opposite of positive 1 is negative 1. And this last one is going to be the opposite of 2, right? But because it has an a, you're going to put it over 3, so negative 2/3 for the last one. So those are the three solutions for this cubic equation. Okay, the square root property. It's not something that I really focus on a ton. You could, if you wanted to, always go back to trying to use factoring or something else. But with square root property, essentially is you have your variable squared, and you don't have any other variables. So like on all these other ones we've done, for the most part, they've had x squared and an x, except for that difference of two squares. And so solving that difference of two squares problem, which we did here, we could have moved the minus 25 to the right side and then use this square root property by taking the square root of both sides. So that's what I'm going to do with this one here. And so I'm going to rewrite x squared equals 8. I'm going to take the square root of both sides, all right, to get x equals, and make sure you put plus or minus the square root of 8. If I want to break down that 8 in there, I could break that down into the square root of 4 times the square root of 2. So simplified, it's plus or minus 2 times the square root of 2. All right, this one isn't ready yet for me to use the square root property. I need to move that 1 to the other side. So 7 minus 1 would be 6. And then I need to divide both sides by 4. And I'm going to reduce that to give me 3/2. Okay? Now I'm going to take the square root of both sides. All right, and I'm going to write x equals plus or minus the square root of 3/2. And I'm not going to leave that, right? You learned in Algebra 1 that you need to rationalize the denominator. So I'm going to rewrite that as the square root of 3 over the square root of 2 and then rationalize the denominator. Hopefully you recognize these steps from your algebra days, which is going to give me the square root of 6 over 2 with no more radical. So I'm going to write this answer as x equals plus or minus the square root of 6 over 2. All right, now let's do one more, and then we'll get into the next the next main method, which is completing the square. So this one, let's get that 3 over to the other side. 15 divided by 3 is 5. I'm going to take the square root of both sides now that I have just my whatever is being squared on one side. So I have x minus 4 equals plus or minus the square root of 5. Not done yet. Let's move that minus 4 over with addition to get 4 plus or minus the square root of 5. All right? Okay. Now, this next method that we can use to solve quadratics is called completing the square, something you would have done in your Algebra 2 days. All right? And there are lots of steps involved, but what I really want you to focus on is, yes, you need to be able to practice and do it, but I really want you to get good at recognizing like when this process would make sense. Like, for example, you'll notice since my a has to be 1, if my term in front of, I should say my coefficient in front of x squared, which is a, if it's not 1, I've got to divide everything by that 1. And if it makes my letter b into an odd number or a fraction, I'm not going to do that because the method here says that you have to take your b, which in this case is -6, divide it by 2 first, and then square it. And so if you're taking an odd number and dividing by 2, you're going to be dealing with fractions. And you know me, I love fractions. I'm a totally big fan of fractions, but there's no reason to make this more complicated when I would just have a simpler time using the quadratic formula. So I don't want you to think that I don't use this. I definitely do. If I notice that a is 1 and my b is even, I'm totally okay with this, and I can do it faster than you could do the quadratic formula, right? Just saying. So let's write this down as x squared minus 6x. I'm going to do this first, all right? Because usually they show it like this. And when you try to factor this, you'll notice there are no factors of -13 that add to -6, right? The only factors of -13 are 13 and -1, or -13 and +1, and those will not add to -6. So I recognize that this a right here is 1. My -6 is even. So I'm going to write it how it was before and move that -13 to the other side. But notice I left a space. And this right here, this space, is where we do our add b over 2 squared. So that's how you complete the square. All right, so in this case, my b is -6. -6 divided by 2 is -3. -3 squared is 9. So I'm adding 9 to both sides. Don't forget to do both sides. Now, the whole point of this, I'll write it again. Normally, I wouldn't write this step. I want to show you. Be very thorough. That now, if I wanted to solve this, we have specifically, right, this is on purpose, created a special quadratic trinomial called a perfect square trinomial. It always factors as a binomial squared. So in this case, I tell students to always go back to right before you squared, right? That -3 is always going to match inside these parentheses. So that's going to be x minus 3 squared equals 22. So now, once I have that, I am ready to take the square root of both sides. I don't know what's happening outside my room, but I'm worried. Very loud noises. All right, it's ending. We're good. Take the square root of both sides, and you get x minus 3 equals plus or minus the square root of 22. Now, 22 doesn't have anything in it that I can factor out that is a perfect square, right? 11 times 2 is not helpful. So to finish this, you're just going to move the minus 3 over and write 3 plus or minus the square root of 22. All right, and that's the process for completing the square. Again, I want to be very honest with you, is I use it, but very rarely, only when certain things happen where I can't factor it. A is 1 and my B is even. If it doesn't check all those boxes, I'm not doing it, right? Hopefully I can factor it. If it doesn't check the boxes of A is 1 and B is even, then I'm using the quadratic formula. I'm not going to stress on my time. I will say if A is not 1, but I can divide all the numbers by A and B is still even, fine, then I'll use it. But I'm not that worried. Oh, I should have said here, A must equal positive 1. Sorry about that. I'm not worried if I can't use this. All right, so that leaves us with our final method, which I always view this, just personally, as a last resort method. That's the way I always view this. I know some teachers will teach it differently, some students will think about it differently, but I don't want to use this unless I really have to, because it's very, very cumbersome is the word I would use, where it's tedious, lots of work to do, and many options, or many opportunities, I should say, for making a mistake. So I know I have it memorized. You need to as well. The quadratic formula, it's a beautiful song. My voice is not great right now, but I'll give it a shot here. Ready? X is equal to the opposite of b, plus or minus the square root of b squared minus 4ac, all over 2a. There you go. All right, so this is a is 1, b is 1, and c is 2. So, full disclosure here, right? I would try to factor it. I can't think of factors of 2 that add to 1. A is already 1, and my b is not even. So I actually would use the quadratic formula here. I would write x equals the opposite of b, plus or minus the square root of b squared minus 4 times a times c, all over 2a. All right, so it's going to be -1 plus or minus. We have the square root of 1 minus 8, which is -7, all over 2. I can't do anything with that 7, but hopefully you remember from Algebra 2 that we can't take the square root of a negative, so we put that letter I in front to denote that this does not have any real solutions, okay? It only has complex or imaginary solutions. So if you were to graph this, right, and feel free to type into Desmos, but in Desmos, you're going to see a curve or parabola like this, and what you should notice is it doesn't touch or cross the x-intercept, so it doesn't have any real solutions. Let's try this one. All right, so A equals 9, B equals 3, and C equals -2. Notice I'm just using the quadratic formula, but I would check to see if I could factor this. All right, I would use my slide divide bottoms up to see if this would be factorable first, because if it is, I can do that way faster than this. So x equals opposite of b, plus or minus the square root of b squared minus 4 times a times c. That's a -2. We'll try to get that again. All over 2a. All right, so that's going to be -3 plus or minus the square root of, let's see, 3 squared is 9. Then we have 4 times 9 times 2. So that's going to be 72, right? Positive 72. So we have 9 plus 72, which is 81. All right, so that's going to be equal to -3 plus or minus, I do know the square root of 81. It is 9 over 18. So I have two answers. One where it's x equals -3 plus 19. 19, silly, plus 9 over 18, or x equals negative 3 minus 9 over 18. So interestingly enough here, because I had a perfect square underneath that radical, I am going to get numbers that do not need radicals for my solutions. So it's going to be what, 6 18ths, which is 1/3, negative 12 18ths, which is negative 2/3. All right, so all this tells me is that I would have been able to factor the original equation there. All right, the very last thing. We can consider the discriminant, which is the b squared minus 4ac, so underneath that radical. And in math, we say whatever's under the radical is called the radicand. So the radicand in the quadratic formula is called the discriminant. It gets a special name. And if you were to find that b squared minus 4ac value as a number, it will tell you what type of solutions you would get. So, for example, this first one here that we did, right, -7, I'll go ahead and highlight them. -7, because that's a negative number as my b squared minus 4ac, the discriminant is negative. I have two complex solutions. This one was a perfect square that's underneath there. So that means I'm going to have two rational solutions. And notice 1/3 and negative 2/3 are rational. All right, the other options, so that was the first one and the second one. Excuse me, not the first one, the last one and the second one. And the other options is if you get 0, you get one rational solution. And if you get a positive number underneath that radical, but it is not a perfect square, then you get two irrational solutions. So you'll still have radicals in your answers. All right, so let's try these 4. So part A, we have b squared minus 4ac, which is going to be 4 squared minus 4 times 1 times c. So that's 16 minus 16, which is 0. So that means I have one rational solution. Again, if you need to look at the table, please feel free to look at the table to make sure you're getting the correct stuff here. Okay, letter B is 14 squared minus 4 times A times C. So that's going to be 14 squared, which is 196. 4 times 8 times 3, that's going to be 96. And 196 minus 96 is 100. Because that is a positive and it's a perfect square, I'm going to have two rational solutions. Let's do C. C has b squared, so negative 5 squared minus 4 times A times C. So negative 5 squared is 25. Then negative times a negative is going to give me addition, so that's good. 4 times 3 is 12. 12 times 2 is 24. 25 plus 24 is 49. Another perfect square. And it's positive, so two rational solutions. So just like letter B. All right, and finally, letter D has negative 10 squared minus 4 times 3 times 15, which is going to be 100. And then 3 times 4 is 12. 12 times 15 is going to be, let's see, that's going to be 180. Let me take a moment. I don't know if I did that right. Yikes. I think that's 180. Let's confirm. Yes, it's 180, so 100 minus 180 is going to be negative 80, and that's a negative. So I'm going to have two complex solutions. All right, so that's how you can decide or characterize the solutions before you actually solve them. All right, don't forget, at this point, you are ready to try some practice problems.